Because of the unique, robust design of the BSCGIV gas injection valve, we are able to provide a new, relatively inexpensive, and reliable surface-controllable gas lift valve to industry, offering several features that are an advantage over currently deployed gas lift technology. In this video, we will show you how this valve is easily configured for your specific well's gas lift design, and also demonstrate how the valve's performance is not affected by changes in the tubing and/or casing pressure. We have built a test instrument to simulate the system functioning downhole. To operate these valves, there are three controllable functional components. These are the same components that are interfaced with in a well application. Number one is the casing pressure, which is your injection pressure. Number two is your tubing pressure at the station depth. And number three is the required hydraulic pressure that's open and closes the valve at that depth. For this demonstration, we're going to set the casing and tubing pressure based on the design of well conditions, and then adjust the valve's power section, Belleville spring, tension to match the exact required hydraulic pressure to open this valve according to the gas lift design. Let's say our gas lift design has casing pressure equaling 1200 psi, tubing pressure equaling 750 psi at this station, which is 6,000 feet, and requires hydraulic operating pressure at the surface of 600 psi. Because the control line is filled with hydraulic oil, which weighs 0.385 psi per foot, we have to account for that in our valve setting. To make this accommodation, we need to add 2,310 pounds to our 600 psi surface required to get the valve operating like it will at depth in this test apparatus. Here's how we do it. The first thing we do is we adjust this knob here, which puts casing pressure at 1,200 psi. You can see our gauge is set at 1,200 psi. The second thing we do is we adjust our tubing pressure, which we don't have a gauge over here. We have a gauge right here, to 750 psi. And then the third thing we do is we operate the hand pump to find out what the hydraulic pressure is opening the valve in these conditions, and we adjust it with our tuning rod on our valve. So let's watch how that works. We pump it, start to increase the hydraulic pressure. As we increase hydraulic pressure, we're at 1,000 pounds. We have not put enough force in this. The valve is still closed. We pump on up to 2,000 pounds. The valve is still closed. As we increase hydraulic pressure, however, though, at about 2,800 pounds, the valve is cracking open. If I pump more force into it, the valve is completely stroked open and completely passing gas. So I'm going to bleed the hydraulic pressure off, the valve closes. But I need to put another 200 pounds plus or minus of force into the valve at this station. The way I do that is, I take a crescent wrench, I come over here, and I adjust this tuning rod on the end of my valve. And it's going to take roughly about 1/4 of a turn crescent wrench isn't too cool. 1/4 of a turn, and we're going to pump this up again and see how much it's changed our hydraulic pressure. $29.10, the valve is opening. If I pump more force into the hydraulic line, you'll see the valve stroke. You'll hear it audibly with the gas passing through it. So now the valve is completely open and gas is passing through it. As I bleed the pressure off, valve closes. Because our BSCGIV valves function directly in response to hydraulic pressure in the control line and not to differential pressure between tubing and the annulus, they're almost completely agnostic to surge changes in casing and/or tubing pressure. Let me show you what I mean. Recall, we're now setting with casing injection pressure to be 1,200 psi, tubing pressure to be 750 psi. But let's say for some reason your casing annulus gets a surge pressure of 2,000 psi at the station depth. So what I'm going to do is I'm going to adjust the casing pressure up to 2,000 psi. So I put an additional 2,000 psi, or additional 800 psi which is an additional 800 differential pounds pressure on the system. And now what I'm going to do is I'm going to pump the valve up, and we're going to see how much the hydraulic pressure changed with that big change in differential pressure. When I pump it up, it's still opening about 2920. Very slight change. So, very, very slight change. We can design our BSCGIV lift system where the deadband between stations will enable us to ignore this minor variance, and in effect, your valve will respond only to opening pressures screwed into your valve's power sections. In summary, the valve is easy to set, simple to operate, and you control which station is taking gas injection. The BSCGIV is a perfect alternative to current gas lift valve technology, where gas injection control is paramount to your operations.